In 2018, a massive fissure tore across a road in Kenya overnight, damaging homes and cutting off a major highway. Headlines around the world screamed the same thing: Africa is breaking in two. But here's what almost nobody told you: the real story is slower, stranger, and scientifically far more interesting than the viral photos ever showed. Let's dig into it. In March 2018, in Kenya's Narok County, near the town of Mai Mahiu, residents woke up to something out of a disaster movie. A large fissure had torn through the earth in some places, measuring roughly 20 meters wide and about 15 meters deep. It sliced straight through the busy Mai Mahiu Narok highway, and it damaged nearby homes. Aerial photos showed a raw brown scar cutting across green farmland, wide enough to fit a small building inside it. Within days, the story exploded across international media. Newspapers, TV segments, and social posts all ran some version of the same headline. Kenya, and by extension, Africa, was splitting apart in real time, right before our eyes. Here's the twist most viral posts left out. Geologists who studied the Mai Mahiu fissure up close reached a more careful conclusion. The Geological Society of Kenya sent teams to investigate, and their chairperson at the time, Gladys Kianji, said publicly that the cracks had nothing to do with the continent splitting apart. The strongest evidence pointed to a specific mechanism. The area sits near two old volcanoes, Mount Longonot and Mount Suswa, which left buried channels and pockets of loose volcanic ash underground. Unusually heavy rainfall in early 2018 washed that buried ash away from below, and the ground above collapsed more like a large-scale sinkhole than a tectonic rupture. That's not quite the whole picture, though. Later analysis suggested the story may be a bit more layered than just rain. Some subsequent research proposed that magmatic activity, including possible minor movement of magma underground and the reactivation of existing fault lines, may have helped weaken the ground in the first place, creating a structural weak point that the rainfall then exploited and finished off. So the safest, most accurate summary is this: the strongest evidence points to rainfall-driven erosion and collapse of buried volcanic material as the immediate cause of the Mai Mahiu fissure, while underlying tectonic and magmatic activity may have helped create the weakness that the rain took advantage of. So, was the Africa is splitting story of 2018 fake? Not exactly, and this nuance is what makes the real story so much more interesting than the myth. The Mai Mahiu fissure was not, by itself, solid proof of the continent tearing apart in real time, but it happened to open up directly on top of one of the most geologically active landscapes on the planet, the Great Rift Valley, which is itself just one visible piece of a much larger tectonic system called the East African Rift System, or EARS. It's worth being precise about that distinction, because the two terms get used interchangeably, but mean different things. The Great Rift Valley is the visible landscape, the valley floor, escarpments, and lakes you can see and stand in. The East African Rift System is the underlying tectonic structure, an actively developing divergent plate boundary between the Somalian and Nubian tectonic plates, as geologists describe it. The valley is the scenery. The rift system is the machinery underneath it. That machinery is real, active, and has been operating for around 25 million years. The East African Rift System stretches for roughly 3,500 kilometers as its core trunk, running from the Afar region of Ethiopia in the north down through Kenya, Uganda, Rwanda, Tanzania, Malawi, and into Mozambique, with several interconnected branches and extensions that make the full network considerably larger. It's one of the biggest active rift systems on Earth, dotted with volcanoes including the iconic silhouette of Mount Kilimanjaro, deep rift lakes. Hot springs and geysers. To really see this system in action, we have to go back further than 2018 to an event in Ethiopia that scientists still consider one of the most dramatic rifting episodes ever observed on land. In 2005, the Dabahu area of Ethiopia's Afar region experienced a rupture along roughly 60 kilometers of rift as magma forced its way upward through the crust. This wasn't a slow crack widening quietly over years. Much of the actual magma intrusion happened in less than a week. The episode included more than 160 earthquakes above magnitude 3.9, a volcanic eruption, an estimated 5 cubic kilometers of magma pushed into the crust, and ground displacement of up to roughly 8 meters in places. Researchers who happen to already have monitoring instruments in the region were able to document the entire sequence, and it became one of the most important natural laboratories on Earth for understanding how continents actually break apart. Because, for the first time, scientists could watch a major rifting episode unfold in near real time, rather than reconstructing it afterward from ancient rock layers. So here's the real picture. Before we even get to the deeper science, East Africa sits on top of a genuine, active, millions of years old rifting system. Individual viral news events like the Mai Mahiu road collapse often get pinned entirely on the continent splitting.
Africa is splitting.
When the immediate trigger is usually something more local and complicated, like rain, driven erosion, interacting with existing volcanic geology. But the broader tectonic system underneath all of it is doing something remarkably similar to what the headlines claim, just unfolding across a timescale no single crack and no single human lifetime could ever fully capture. That raises the obvious next question. If it's not a sudden road-splitting crack, what is actually driving this process deep underground? What's really happening dozens of kilometers beneath the surface that could, over enormous stretches of time, turn one continent into two? To answer that, we need to talk about tectonic plates, mantle plumes, and one of the most unusual three-way geological meeting points on the planet. Before we go further, let's clear up one important piece of vocabulary, because it changes how you should think about everything that follows. What's happening right now is not, technically, Africa splitting into two continents. Strictly speaking, Africa's crust is being stretched along an active plate boundary, and two tectonic plates within it, the Somali plate and the Nubian plate, are gradually moving apart. Only if that rifting eventually runs its full course and produces an ocean between them would we accurately be able to call the result two separate continents. Right now, we're watching the early chapters of that story, not the ending. With that clarified, here's how the plates themselves work. Most of Africa sits on the Nubian plate. Over millions of years, a smaller piece has been gradually separating from it, the Somali plate, which carries Somalia and parts of Ethiopia, Kenya, and Tanzania. These two plates are diverging, moving apart, but not at one uniform speed everywhere. Research generally puts the relative motion at only a few millimeters per year across much of the rift, reaching roughly 6 millimeters per year in some of the fastest moving sections, particularly near Afar. That sounds insignificant on a human timescale, and it is. But sustained over millions of years, even motion that's small can reshape entire continents. Plate tectonics simply doesn't operate on a clock that means anything to us personally. There's one location where this story becomes especially remarkable: the Afar region of Ethiopia, home to what geologists call a triple junction, one of the rare spots on Earth where three separate rift systems meet at a single point: the main Ethiopian rift, the Red Sea Rift, and the Gulf of Aden Rift. Three tectonic plates, Nubian, Somali, and Arabian, are all pulling apart from each other here at once. It's considered one of the best natural laboratories on the planet for studying how continental crust gradually transitions into oceanic crust. What's actually driving the pulling apart? One major factor appears to be an unusually hot upwelling of material from deep in the mantle beneath Afar, commonly described as a mantle plume. But researchers are careful not to treat the plume as the entire explanation. Plate forces, the structure and weaknesses already built into the African lithosphere, and the way magma moves through the crust all interact to drive the rifting process. It isn't a single simple cause. Recent research has added an intriguing wrinkle to the plume side of that story. A 2025 study, led by researchers including teams from Swansea University and the University of Southampton, analyzed more than 130 volcanic rock samples and found chemical evidence suggesting the mantle plume beneath Afar may rise in rhythmic pulses rather than a smooth, constant flow, an effect the researchers themselves described as resembling a slow geological heartbeat. As the crust stretches and thins over millions of years, it goes through a process geologists call necking, the same term used to describe how a piece of taffy thins right before it snaps. This is where the most important and most recent piece of the story comes in. A landmark study published in Nature Communications in April 2026 examined the Turkana Rift, a roughly 300-mile-long stretch spanning Kenya and Ethiopia, and found that the crystalline crust beneath it has already thinned to around 13 kilometers along the rift axis. The researchers, including geoscientist Christian Rowan, dated the onset of this necking process to approximately 4 million years ago and described the Turkana Rift as the first known active continental rift. Caught in the act of undergoing this stage, a genuinely rare opportunity to observe, in real time, a phase of continental breakup that scientists have mostly had to reconstruct afterward from ancient, long-finished rift zones elsewhere on Earth. Crucially, the paper's authors were careful to note that this evidence of necking does not mean present-day breakup is imminent. It means this section of the rift is primed for eventual breakup, which is a very different claim. This same tectonic instability appears to have shaped human history in an unexpected way. The active rifting and volcanic activity around Turkana created the geological basins and rapidly accumulating sediment that helped preserve an extraordinary fossil record of human evolution, including the nearly complete skeleton known as Turkana Boy, among the most complete Homo erectus remains ever found. The same forces that could someday create a new ocean also helped preserve some of the most important physical evidence of our own species' deep past. Now, the question a lot of viewers are actually asking underneath all of this: Is any of this dangerous? Not in the way disaster headlines imply. A continent gradually rifting apart over millions of years isn't a threat to anyone alive today. And there is no credible scientific basis for imagining some sudden catastrophic snap. But the rift zone itself is already a genuinely hazardous place to live. In more immediate, everyday ways, it's associated with real earthquakes, active volcanoes, ground subsidence, and landslides, especially when heavy rains interact with unstable volcanic soil, exactly as happened at Mai Mahiu. So the honest answer is, the slow-motion splitting of a continent isn't dangerous on any timescale that matters to us, but living directly on top of an active rift system comes with real, present-day geological hazards that have nothing to do with continents actually separating. So how fast is all of this really happening? And what would the eventual result actually look like on a map? That's what we're covering in the final part of this video, along with an honest look at exactly how uncertain that future map really is. Let's talk about what scientists think could eventually happen along the eastern edge of Africa, with the emphasis firmly on could, not will. If the rifting continues uninterrupted through complete continental breakup, and that's an important if, since not every active rift on Earth actually finishes the job, some slow down, stall, or fail entirely. The broadest scenario researchers describe involves the Somali side of the rift eventually separating from the much larger Nubian side. The eastern landmass could include Somalia and substantial portions of Ethiopia, Kenya, and Tanzania, though the actual future boundaries would likely be far more complicated than a clean two-piece split, since the East African Rift system also involves several smaller tectonic blocks, including the Victoria, Rovuma, and Luandel microplates, that would almost certainly complicate any simplified future map, if the continental crust eventually ruptures all the way through. Seawater from surrounding ocean basins could flood the newly formed depression, and continued seafloor spreading new oceanic crust forming along the spreading center would gradually build that flooded depression into a genuine ocean basin over time. This is essentially the same mechanism that, tens of millions of years ago, once separated South America from Africa entirely and created the Atlantic Ocean. As Arizona State University geologist Christy Till has put it, a rift very much like this one is what once separated those two continents and formed the Atlantic. What's happening in East Africa right now may represent the very early stages of a similar process. It's a useful mental model to hold on to. The East African Rift today represents early-stage continental rifting, while the Atlantic represents what that same kind of rifting looks like after it is fully finished, tens of millions of years later. That possibility, a genuinely new ocean basin forming where dry land currently sits, has led some researchers and science writers to describe it as a potential future ocean, sometimes dramatically nicknamed Earth's sixth ocean. It's worth being clear that this is a popular, informal label rather than a formal scientific classification. The number of Earth's oceans is partly a matter of geographic convention to begin with, and no new ocean is currently recognized or guaranteed. It's a vivid way to describe a real possibility, not a settled prediction. And that word possibility really is the load-bearing word for this entire final section. It's tempting, and it's exactly what most viral headlines do, to state flatly that Africa will split and a new ocean will form. But the more scientifically honest framing is that if rifting continues along its current trajectory, the eventual result would likely be a new ocean basin between the separating land masses. The rift is clearly active and clearly primed in places, but active rifts elsewhere in Earth's history have also stalled out or failed before reaching full breakup. And scientists studying East Africa are careful not to treat complete separation as a foregone conclusion. On timelines, you'll see a range of numbers thrown around in different articles, figures like 5 to 10 million years. Or several million to tens of millions of years. Rather than picking one number and presenting it as a countdown, the more accurate summary is simply this. Scientists are talking about a process measured in millions of years, and there is no precise timetable. Even the 2026 Nature Communications study on the Turkana Rift, which found some of the strongest evidence yet that part of the system is primed for breakup, explicitly emphasized that present-day breakup is not imminent. Despite that evidence, primed describes a stage in a very long process, not a countdown to an event. To put that timescale in human terms, modern humans have existed as a species for roughly 300,000 years. Even the more conservative multi-million-year estimates for continental breakup here represent a span of time many, many times longer than the entire history of our species so far. This is not something that will happen in our lifetimes, our children's lifetimes, or within any span of recorded human history going forward. That's really the heart of the real truth behind this story. It isn't a hoax, and it isn't fear-mongering nonsense. Either it sits in a genuinely fascinating middle ground. A real, scientifically significant tectonic process is underway right now, driven by real diverging plates, a real mantle plume, and one of the most unusual triple junctions on the planet. But the viral moments that usually introduce people to this story, a fissure swallowing a road, a sinkhole opening in someone's farmland, are almost always faster, more local events. Like erosion interacting with volcanic geology, layered on top of, but not directly equivalent to, the deep, slow-motion tectonic story running underneath them. What makes the East African Rift such an extraordinary place isn't that you can watch a continent visibly split apart on the evening news. It's that it may be one of the only places on Earth where scientists can study, in real time, an entire life cycle of continental rifting from the first cracks and volcanic activity, through crustal thinning and necking, toward what could eventually become a new coastline.
This time-lapse reveals the dramatic thinning of the continental crust.
And possibly a new ocean, if the process runs its full course. It's a working geological laboratory, sitting in plain sight, connecting the deep past like the ancient hominin fossils preserved in its sediment to a deep future that no human being alive today will ever personally witness. So the next time a headline claims a crack in a road proves a continent is splitting apart overnight, you'll know the more accurate and honestly more remarkable version of the story. Africa's crust really is being pulled apart along an active tectonic boundary. Whether that process ever finishes and produces two true continents separated by a new ocean is still an open question that only many millions of years will actually answer. If you found this fascinating, subscribe for more deep dives into the science behind the headlines, and let me know in the comments, do you think this rift will actually finish the job?